Now I've got a nice little antenna for us to take a look at today on the channel, and I picked this up off eBay. Picked this up pretty cheaply because the mounting part of this antenna is missing, so it's a little bit difficult to mount with this L bend N-type connector coming out of here, but I suppose you could fabricate something if you want to. These go for around £50 if you wanted to buy them from the company or one of the resellers. It's a German company, it's a well-known German company, so it's always nice to take a look at some of the more professional antennas. I don't know what's going to be on the inside of this, but we've got a few specs here. The frequency range is basically 2.3 gigahertz to 2.5 gigahertz. The VSWR is 1.5, so that's nice. The gain 11 dBi. Yep, that's a nice little bit of gain there for something with such a small footprint. The front to back ratio minus 20 dBm. I've mentioned that before in previous videos and people have asked, and basically you've got a directional antenna because you've got a back reflector, and microwaves will pass through metal. The thicker your back reflector, the less energy you have in pass through there, so you have a better front to back ratio. This aluminium looks to be about 1 mil thickness, so if you were to put some 3 mil aluminium on the back of this for the reflector, then this would decrease and you get more energy coming out of the front of it. Now, as far as polarization concerned, it's linear, horizontal and vertical, and we've got some nice little images here. It seems to put a little bit more power out on the horizontal than it does the vertical. So let's take this over to the test bench, hook it up to the network analyzer and see what it looks like. So here's the antenna under test then, set up ready to measure the return loss on the network analyzer. So let's take a look at the network analyzer now just to see how well this antenna will perform. So here we are on the network analyzer, and the spec sheet is correct. We have got quite a wide frequency of response there, quite a wide broadband range, but I've got the cursor on 245 gigahertz just here, which is almost bang in the middle of the Wi-Fi networks, and we've got this dip here right in that 2.4 gigahertz Wi-Fi spectrum. But of course it is a pretty wide frequency of response there. It's a very nice response indeed, and this little dip here is going to do the business at 2.4 gigahertz for Wi-Fi. Really nice output here on the network analyzer. So let's take a look at the inside of this then, and there doesn't seem to be any obvious way to get into this. There's no screws or anything like that. The plastic case looks to be vacuum formed, not you know, thicker injection molded plastic, but hopefully if I can get a spudger down the sides here, we should be able to pull this away from the case. So yeah, let me try that and we'll take a look at the inside. Now, I don't want to point out the obvious, but as you can see, I've got the case removed. It was just held in place with some little sticky tabs here on the side, so it's an outside antenna, so I would have liked to have seen some silicone down the sides to stop any water ingress, but you're not going to believe what kind of antenna we've actually got here. And yes, it's a single biquad element, and to be honest, I should have known that by looking at the output on the network analyzer. One of the reasons I love the biquad element, and I tell people to have a go at making this as a first antenna, is because it is so broadband and you can mess up the measurements slightly and you will still get a working antenna at the end of it. Now, funnily enough, I was going to make a post on the Facebook group Antennas regarding biquads, and while we don't see many of them from the professional antenna makers, the companies, and yeah, here's one that's come from a professional company, and it looks quite nice. Let me get the calipers out, we'll do some measurements on this. Now, as for the thickness of the wire they've used 1.8mm thick copper wire here, and that's about the kind of thickness that I use, 1.5mm, around that kind of size. And as I've said in previous builds of biquads, increasing the diameter of the wire that you use can increase the overall bandwidth of the antenna, so you get a wider frequency of operation. But let me measure in between here. This will be an interesting measurement. And here we're getting a measurement of 31.8. Now if you go back on all my 2.4 gigahertz biquad builds, you'll see that I make myself a little measuring tool to measure the inside width here at 31.5. so again, you know, that's the kind of measurement that I use when I'm building my biquad. Some people say that the measurement should be on the outside, but no, I've always stuck to 31.5, and that always gives me a nice performing biquad, and it looks like the professional company has done the same with this one here. Now looking at how they've connected this biquad, it's interesting to see that they've used a piece of PCB material here connecting the two ends of the elements here and here. So I'm going to unscrew this, because it'll be interesting to see if they've actually grounded it to the back reflector, because when you don't ground your biquad elements to the back reflector, it doesn't work as well as one that's grounded. Let's say, you know, a grounded one with a grounded reflector, you'll get better back to front ratio and slightly better performance, and you can actually see that in everyday use of a biquad. A grounded one will outperform slightly, only slightly, but it's still there, will outperform one that's not grounded. And it's always nice to see, you know, the measurements that I've been saying for getting on for 18 years now are spot on measurements being used by a professional company. So yeah, it's very nice to see that. Now I'm going to have to desolder the elements so we can extract this end connector here, but I can already see that it's not grounded to the back reflector, and as I say, that does the reflector doesn't perform as well when it's not grounded. Let's say it's same as shielding. Shielding doesn't perform as well if it's not grounded. It still does a job, but just not as well. And if we go back to the sheet here, where the sheet says this is 11 dBi of gain, I would question that with the reflector not being grounded. And as I say, I've built both over the years, last 18 years or so, maybe even a little bit longer, and I've always found that grounding the back reflector gives an increase that you can see in the real world over one that's not grounded. So I would have to question that and say that you know, with this reflector not being grounded, I would say that it's operating at about 9.5, maybe 10 dBi of gain. Let's say 10 dBi of gain without the reflector not being grounded. Just in my opinion anyway, with the experience that I've got on building biquads. Now looking at the connector, it's interesting that we've got the ground here where the elements are soldered onto, and the ground is kind of tapered, and we've got the main driven element part here, which is a straight piece. So they've tapered the ground, and I'm wondering if that's to lower the VSWR some. But this is the connector, and it looks like we've got two pieces here, and they've glued the two halves together. So I'm going to try and part it around this line here so we can extract the N-type connector and take a closer look at this PCB. So here's the PCB and the N-type connector. Now this is a box standard N-type connector. It's not been manufactured just for this job. They've used an off-the-shelf part, and you can see here the tapered PCB here. That's feeding one end of the elements with the ground here, and if I flip it over, you can see we've got the little solder cup there, box standard N-type connector, and that's feeding into this trace here, which is feeding the opposite end of the driven element. So I'm presuming that this is going to be a 50 ohm feed line here, and as I say, this tapered piece here, I mean, they could have quite easily used all of this as it is with the copper, but they've gone to the trouble of etching this piece off here. So I'm presuming that brings the VSWR down. That's why you would normally taper a feed like that. Now I wasn't expecting to find a biquad with this antenna at all. I was expecting another panel type antenna for us to take a look at, but when you lay the biquad antenna out in its constituent parts like this, you see straight away that there's just not a great deal to it, and it's one of the reasons why it's my favourite antenna. I've got a few favourites for different reasons, but this is another reason why I always tell people, if you're getting into antennas and you want to build an antenna, build the biquad first, because it's easy. Any mistakes that you make in building the antenna, they'll be lost in that quite wide range of frequency of operation in the bandwidth there, and that's just why I love it. It's such a simple antenna, and you know, if you build it well, especially if you ground the back reflector as well, you're guaranteed 11 dBm every time. It's a really, really nice antenna. So hopefully you enjoyed this quick little video, and I certainly enjoyed taking this apart, and it just verifies what I've been telling people over the last 18 years or so. Yeah, on my YouTube channel since 2012, but online on forums for about 18 years, with the measurement on the inside measurement of these elements is just, you know, spot on what I've been telling people all along to build a biquad at. And yeah, it's nice and surprising to find a biquad from a professional antenna maker. If you were to pick one of these up and you were going to put it outside, mount it outside as a point-to-point kind of setup, I would certainly look at putting some silicone sealant on the inside of this, just to you know, make sure you don't get any water ingress. But apart from that, I can't really knock it. The only thing is the back reflector's not grounded, but you know, that's just a minor thing. Comments and questions, drop them below and I'll do my best to answer them. And yeah, if you want to help support this channel and get things like this in to take a look at without the sponsorship rubbish at the front of the video, then please you know, feel free to pop along to Patreon, help support this channel, and hopefully you'll join me on the next one.